In this example, we're going to look at composing functions algebraically. The functions we have here are the functions j and k, where j of x equals 5x squared plus 3x minus 1, and k of x equals 2x minus 1. For this first example, we'll look at k composed with j. So we'll start with this k composed with j of x, and we'll write that as k of, and inside there goes j of x. So as we're looking at this, the first thing we're going to do is we're going to replace that j of x with how that's defined. And it's defined by 5x squared plus 3x minus 1. And this is the basis of how function composition is going to work. We have j of x inside this function k. So in order to compose those, we'll replace that with our expression for j of x, and then we'll apply that function k. So if we look above, we can see that k is defined by k of x equals 2x minus 1. So whatever we input into that function k, it's going to follow the same pattern. If we come off to the side and look at this in a little bit more abstract way, k of whatever we have inside here will then equal 2 times whatever that input was, minus 7. So its formula is based on x, but here we're putting 5x squared plus 3x minus 1 into our function k. So as we apply function k, what will happen is we'll get 2 times, and what's inside that function k is 5x squared plus 3x minus 1. And then we still subtract 7 based on the definition of k. So at this point, all we have left to do is simplify that expression. So I'll distribute that 2, and I'll get 10x squared plus 6x minus 2, and I'm still subtracting 7, and then my last step is just to combine those like terms. So I'll get 10x squared plus 6x minus 9. Okay, so there we've taken k composed with j. In this next example, we're going to do the reverse, and one of the things we want to know is that function composition is not commutative. So k composed with j is not the same function as j composed with k. So let's work this one out, and we'll see that quite clearly. So we have j composed with k of x, and that's j of k of x. So k of x goes inside. And now what we'll do is we'll apply that function j. And again, j of x is defined by 5x squared plus 3x minus 1. So when we take j of k of x, we have j of, and inside there is 2x minus 7. And as we apply that, it then becomes 5 times that expression, 2x minus 7. And that quantity is squared, plus 3 times that expression 2x minus 7, and then we're subtracting 1. So at this point we've composed j with k, and now we're just going to simplify. So this 2x minus 7, that quantity is squared, so we need to make sure that we fully FOIL that out, and we'll get 4x squared minus 28x plus 49, and that's still inside parentheses. That whole trinomial there will be multiplied by 5. Continuing on, we'll get plus 6x minus 21, and then still minus 1 on the end. All right, so a couple more steps here. We'll distribute that 5. We'll get 20x squared minus 140x plus 245, and then still adding 6x, and then I'll combine that to minus 22. And as our last step, we will just combine those like terms that are there. So we'll have 20x squared minus 134x, and then plus 232. So that's our function j composed with k of x, and it's fully simplified.